So this is an area which has been evacuated in recent days?
Yes, exactly. So the evacuation started in November 2023, and we've had various phases of evacuation levels throughout that period of time.
I was just about to say it looks like a fairly normal town until I spotted that. Wow.
It's quite a stark contrast to what we've been walking through.
Iceland, the land of fire and ice, shaped by volcanic eruptions and glacial terrains, with the signs of Mother Nature's most powerful forces surrounding you at every turn.
For the people who live here, the impact can be devastating. But studying the shifting ground beneath our feet offers great potential for better understanding of our planet and its future.
Over the past 4 years, there's been an increase of volcanic activity close to the capital city on the Reykjanes Peninsula, allowing volcanologists to study these eruptions in incredible detail. A volcanic eruption is the expulsion of gases and magma, or molten rock, from beneath the Earth's surface. And once that magma reaches the surface, it's known as lava. We were on standby for the next predicted eruption. From the amount of magma built up underground, this was expected to be the biggest yet. And the remaining residents in the nearby fishing town of Grindavik were quickly evacuated. But Mother Nature can be unpredictable, and the flare-up subsided before we arrived. To keep everyone safe, the area remains on high alert.
People have been evacuated, so we're having to drive through a checkpoint in order to get access. Oh, my phone's just got an emergency message through saying you are in an area that is not safe.
Volcanologist Ricky Peterson leads the way with all the safety gear needed to enter the restricted site of the eruption.
Hi, I'm Rhea.
I'm Ricky. Nice to meet you. Welcome here.
Thank you. We rushed out here on the first plane we could as soon as we heard that the volcano had erupted. But we've been a bit unlucky, haven't we?
Well, actually, it ended in the afternoon, late afternoon. It was a very short-lived eruption, but the main event that really happened was a dike intrusion, and that's when we have magma moving towards the surface, but staying below the actual surface and penetrating into a fissure and widening the whole area.
From this stunning vantage point, we can obviously see a lot. So can we get any closer to the lava and perhaps somewhere a little bit more shaded?
Yeah, absolutely. We will go and visit the lavas and also the lava that was created yesterday, so we can move down in the lowland.
The peninsula had been inactive for nearly 800 years, since the end of the Reykjanes fires in 1240 AD.
So where are we now?
So we're just by this greenhouse.
Right.
The red line you see here going through town, this is Grindavik, is one of the main faults that were activated on November 10th, 2023. So it was the first dike event happening in this area where we had a massive destruction here in town, and that's due to these faults moving.
How safe are we being this close to what's just happened?
So it's safe at this point. We have, of course, our security measurements. We have a gas meter with us. We check, but we have to be careful. There have been fault movements in this area, so we just move with precaution.
OK, I'll stay close to you. Oh, my gosh. Look how much damage that has caused. That's the glass from all of the greenhouse windows on the floor here.
Yeah.
And just looking at it inside, it's like seeing a kind of doll's house that's falling apart. That is incredible. Wow.
It was 15 kilometers long.
Wow.
And it's very thin, so it's creating the faulting we see on the surface here, because it's really pushing the sides apart as it's penetrating from below and up and widening the area. The faulting happened here, and you can follow it all the way into town, so we can go visit here the new lavas.
OK, so this is where we can see the steam coming out.
Yeah, exactly. So these were just created yesterday, and we can go and visit the brand new piece of Iceland.
As we make our way over, the eruption may be over, but you can still feel the power of Mother Nature. A sea of lava stretches out before us, blocking the path ahead. But why exactly is Iceland such a volcanic hotspot? This island is situated on the Mid-Atlantic Ridge, a divergent plate boundary. The North American plate in the west and the Eurasian plate in the east, which are spreading apart at a rate of about 2 centimetres per year. Magma from the Earth's mantle rises to fill the gap, mending the plates or erupting as lava from central volcanoes, fissure systems, or both. The fissures are even given names. Sundhnúksgígar is the row of craters where the latest eruptions have been taking place.
This is the most striking scene. And the closer I get to you, Simon, the warmer it is. Hi, nice to meet you.
Nice to meet you.
This is absolutely incredible. What is it that we're standing next to and looking at here?
Yeah, so this is some of the vents from the eruption that's just taken place. And so all of the rock you see around here wasn't here a few days ago. This is brand new rock. And so as the eruption started, a fissure would have opened along this line you see here. And as the magma is coming up towards the surface, it's being propelled out of that vent by the gases that are expanding as the magma decompresses. That expansion of the gas really throws the magma out of the vent. And all of the rock you see around our feet here are bits of magma that were thrown out and then solidified as they cooled and hit the ground.
Are we safe to be standing this close?
Yes, we can feel the heat that's coming off some thicker lavas that you see here. But just around the edge here, this material is pretty cold now. And so we're safe to go near it and we're safe to collect it.
Good, glad to hear it. And what is it that you're here to collect?
Yes, we want to collect these samples to determine where this magma has come from, what its properties are, and what it can tell us about what's happening underground in the insides of this volcano.
Okay. Can I join you in that collecting
Yes,
sampling
absolutely.
attempt? What can I do? How can I help?
Come this way.
So how many samples will you ordinarily take?
So we'd usually try to fill a bag that sort of size from each location. And although we only need maybe something this size for the analyses we're doing right now, we never know if another eruption's going to come along and completely cover all of this material. And so we want to make sure we've got plenty for the years to come and for any future studies that people want to do.
Professor Matthews and his team aim to collect samples as soon as possible after an eruption has started. If the eruption had lasted a day longer, we could have been doing this. They keep sampling throughout it, and again once the eruption has finished. Being so close to the capital, Reykjavik, he can start to analyse the lava on the same day. But his work is just one element of research at the Nordic Volcanological Centre, known as Nordvolc, at the University of Iceland. I caught up with Ricky Peterson again to find out more.
Tell me about the research that you're doing here at the university into the activity of Iceland's volcanoes.
So a lot of the research done at Nordvolc reflects on or investigates the roots of volcanoes. So it's really a matter of looking into both the sources of the melts coming out on the surface, but it's also looking into the plumbing system, how you have magma coming from very deep depth and moving into the crust. So the ways to study magma plumbing systems, you can study it by geophysics. There's a lot of effort going into GPS monitoring and INSAR. And when we utilize the different techniques, we can really get an integrated picture of what the volcano looks like inside the Earth.
By carefully tracking daily changes in the Earth's surface using GPS, it's possible to measure ground deformation to work out the accumulation of magma. In combination with recording seismic activity and other analysis, they're building a clearer picture of this period of volcanic activity in the Svartsengi volcanic system.
How about the latest eruption? What's happened?
Usually the eruptions keep increasing in size as the stresses inside the ground are relieved. However, the eruption that we saw the other day was the smallest of all the eruptions, but that's due to the fact that most of the magma on the move was channeled to the north and into a new 20-kilometer long dike instead of erupting at the surface. So it was just a small spillover at the surface, which was really fortunate.
So while I was unlucky to miss the eruption, it was a stroke of luck for the town of Grindavik that most of the magma stayed below the surface. When we return, Professor Matthews reveals the valuable insights hidden in his freshly collected lava samples.
You can see more of Razor on our YouTube channel. Search for Razor Science Show and it will take you straight there. Remember to subscribe and hit the bell button for notifications.
Here at the University of Iceland, Professor Matthews and his team have sealed small fragments of lava in epoxy resin, ready to be analysed under an electron microscope.
What you're seeing here is a map of the different materials that the lava is made from. So the geometric shapes that you see here are different crystals of minerals. And so the darker crystals are one type of mineral, and the less dark crystals are a different mineral. And then the grey that's surrounding it, the lighter grey, is volcanic glass. And this is what we want to analyse to get an idea of the properties of the magma and where it's coming from.
So this is enabling you to actually age the sample, much like cutting a tree open and looking at the rings to tell how old it is. This tells you a huge amount of information.
Yes, exactly. So we can get information about how the magma's cooled in the past, and so that can tell us something about, has it just been sat in a single reservoir, or are there multiple reservoirs that are connected together?
It's quite a surprise to know there's such a huge amount of information that you can take from these tiny little fragments of samples.
Yes, and as we discover more, then there are just more and more techniques open to us and more information that we figure out how to use and how to interpret.
It's also a really beautiful picture to look at, isn't it?
Yeah, I really like looking at these images. There's some really fascinating patterns that you see in here. So you even have places where there are minerals that are intergrowing together.
And at this stage, is there anything to be learnt from what we can see on the screen?
It's fairly similar to the lavas that were erupting in the previous eruptions. And so it looks like these lavas are coming from the same magma storage area as in previous eruptions.
As well as using microscopes, they also add samples to chemical solutions in their clean lab to gather even more information. The symbols on these maps of lava flows show where samples have been collected. And the results reveal instead of a single magma body, it's actually a much more complex system of magma rising to the surface from different levels.
What's the impact been of this latest eruption here in Iceland?
So we have, on average, a volcanic eruption of 4 to 5 years interval in Iceland. But of course, recent years, since 21, we've had already 11 eruptions with the most recent one. So of course, the people in Grindavik have been greatly affected by these eruptions and the dike intrusion that fractured the ground in Grindavik. This is a huge impact on infrastructure like that.
It sounds as though living alongside volcanoes, the impact is almost twofold. On the one, it's a negative of having to be displaced from your home, but on the other, it's huge potential for sustainable energy.
Absolutely. I mean, Iceland wouldn't really be inhabitable without the volcanoes. We do utilize the energy from the volcanoes in the best way. We get green energy, we can heat up the houses, we can produce electricity. But of course, that comes with the cost of living in a dynamic environment like this. So when you live in a natural environment where you can have a road one day and the next it may have been destroyed by lava flows, people become more flexible and it's just a way of life.
Geothermal energy powers Iceland, heating around 90% of its homes and generating more than a quarter of its electricity. The geothermal areas also shape Icelandic culture, with hot springs and pools playing a big role in daily life here. It was a chance discovery at a geothermal plant based right next to the recent eruptions that gave scientists a crucial clue, helping them predict this latest string of volcanic activity.
So where are we headed?
We are headed to borehole 12 here at our geothermal plant in Svartsengi. And this is a deep borehole. It's 1,488 meters deep. And inside this borehole, we have a pressure logger that measures the pressure and temperature inside the well every minute. And then we can analyze this signal and see what's happening underground in our geothermal reservoir.
And why do you need to do that?
So first of all, we want to know how our production is affecting the geothermal reservoir. And we use that to optimize our injection, to get the right balance within the reservoir. And then recently, when the eruption period started here in Sundhnúksgígar, we started using this logger to create a warning system for volcanic eruptions. It all started in November 2023 when we had that first big intrusion at Sundhnúksgígar. We noticed that there was this distinct pressure signal in this borehole here at Svartsengi. And when we analyzed that signal later, we could see that it was due to the magma moving. So as the magma is forcing its way through, it compresses the rock to the side, and that rock compression causes the water level in our geothermal reservoir to rise. This happens very rapidly. And therefore, the pressure that we're measuring inside the well, the hydrostatic pressure, increases as the water level rises. We launched this system on January 11th, 2024. 3 days later, we had the second eruption, and the system worked. It sent out the warning 4 hours and 20 minutes before it erupted, giving the Met Office and Civil Defense time to respond to that.
Geothermal energy works by drilling wells to tap into superheated water stored in underground reservoirs. As the fluid rises up the wells, the lower pressure causes it to turn into steam. The steam spins turbines connected to generators, producing electricity. The sensor in borehole 12 continuously monitors the hydrostatic pressure in the underground reservoir. And if it detects a distinct pressure change, an automatic warning is sent out. Since the warning system was launched, it's accurately predicted 6 out of 7 eruptions, only missing 1 due to a server outage.
That was the only time we were not able to warn, and then there was no warning given out to the public before that eruption. So that also helped us understand how important this warning system was.
Grindavik had a population of around 4,000 people when it was first evacuated in 2023, after the first fissure cut through the town. Now it's mostly empty, with only about 100 people choosing to stay. The early warning system is vital for alerting those remaining residents, as well as a nearby popular tourist destination, the Blue Lagoon Geothermal Spa area. Researchers from the University of Iceland are also mapping the extent of the newly opened fissures.
So this is an area which has been evacuated in recent days?
Yes, exactly. So the evacuation started in November 2023, and we've had various phases of evacuation levels throughout that period of time.
I was just about to say it looks like a fairly normal town until I spotted that. Wow.
It's quite a stark contrast to what we've been walking through.
What is this?
This is one of the main fault lines that runs through the town. It was activated in November 2023,